Hey, sorry I'm not there today. Yesterday in class we started working on evaluating indefinite integrals. And it's a new procedure. It takes some time to get used to. You notice there's a lot of problems in here. They're just easier when they're done with multiple choice. But we're going to try a couple of them together. But before we do, let's talk about what the steps are to evaluating indefinite integrals. Okay, step one is going to be remove fraction if possible. And what I mean by that is there are several times the problems will look like this, where you will see the original problem written as a fraction. So our first step is always remove those if possible by moving up the number on the bottom and putting it to the negative power. I forgot my dx there. Oh, I know, I'm going to fill that in just a second. 10x x squared plus 2x to the fifth dx. So that's always step one, is to get rid of a fractional component if it can be done. Okay. Step two. Okay, step two is to move constants out front. It's not mandatory, but it's a good idea because there are numbers usually you're not going to use. When I'm setting up the first problem right here, I could take this 7, and instead of having it inside the radical sign, I can put it out, not radical sign, integral sign, I can put it outside the integral sign. This is only true for constants. Down here, I've got this 10. The x has to stay. And I can move it outside and deal with it at the end of the problem. This is useful later on as well when we're adding more parts in. Now for the third step, which is, so our third step is going to be make sure the inside derivative is there. On this first function right here, there's no inside functions. It's just an x. So we could integrate this one without having to worry about the inside function. So this one would go x to the up 1 power negative third, and it'd be a negative 1/3 out front, plus c, and then the 7 that's already here stays there as well. This is obviously times, and I could simplify that to negative 7 over 3x to the negative third plus c. So it's just a power rule. That's how you work it. Now, when we have an outside and inside function, we look here, here's our inside function. We can't move ahead unless we have the derivative of the inside function sitting there. So the derivative of the, okay, so I just bring this one to another page so I can see it a little better. Once again, just make sure I'm writing it down right. X squared plus, oh, which way? 2 to the fifth dx. So once again, I'm looking at the inside function, and I'm going to write down what the derivative of the inside function is. That would be 2x. Now the only way for this to work is if I had I need to have a variable, the x, lying around. And look, I have one lying around right there. I'm going to rewrite it over here, and I'm going to erase it because I just moved it. And now I almost have what I need to proceed, but I need a 2. So I'm going to put a 2 in here. But that changes the problem, so I'm putting a 1/2 on the outside to counteract that too. So now I have my inside derivative sitting there. I have an extra constant on there. I'm ready to proceed. When I integrate, you can think of these as derivative parts. The integral sign cancels those out. They're gone, and I'm integrating just something to the fifth. Well, the integral of something to the fifth is something to the sixth times 1/6 plus c. And then the additional 1/2, any constants I have lying around have to come with me. And I can simplify this to 1/12 x squared plus 2 to the sixth plus c. So that's our integral. So it's always about that process. The layer of the problem is you find the inside function, set it off to the side, and counteract with constants. So let's take a look at some of the multiple choice problems you have to work on. So just so you know, in your packet, there's an additional page 1. That's for a different day. So just make sure you turn to this page 1 right here, which says evaluate each indefinite integral. So I'm just going to identify a couple of them. Some of the ones here are, let's take a look at 1. I see it's a fraction. So I'm going to change it immediately to the integral of negative 3x to the negative fourth. I brought that power up. At which point I already know it's going to be one of two answers. There's the dx when I integrate it. I know it's going to go to the negative third power. So I've got negative 3 is already there. X to the negative 3, and the flip of that is negative 1/3 plus c. 3's and those cancel out. And so it's x to the negative third, which is that answer right there. No product rule involved. Sorry, no inside function involved in that one right there. The first 5 on there are pretty straightforward. I'm going to leave those for you guys to do. And then we're going to take a look at number 6. 6 introduces the inverse trig functions without something stuck inside of it. And remember, it's the inverse trig functions when, if kacI0bw appears in the end, that's when our tiers will start to fall. So let's take a look at number 6. It says cosecant squared x. Well, I know that the cosecant squared is the derivative of cotangent. Cotangents, cosecants. And because a co appeared, it's going to be negative. So the correct answer is going to be choice B for right here. When I see one like this, I already know right where I'm going to go. I know it's going to be a, if it was secant tangent, it'd be secant. So it's going to be cosecant. And did kacI0bw appear? Sure he did. So it's going to be negative. There's one there. Okay, the derivative, the integral of negative sine is going to be, I know it's going to involve cosine of x. Now there's already a negative sign there, and co appeared, so another negative sign appears. So the correct answer should be cosine of x. And this is the one people have the most trouble with, but in the end, if you just work it backwards, what's the derivative of cosine? And here's where we start to get in trouble because we're going in both directions. The derivative of cosine is negative sine. So on these multiple choice ones, you can always just look at the answers and say who would have a derivative of the one that's there. So for example, I've got 10, which is negative 5 secant squared x. So what has a derivative of secant squared? It's not cosine. It's not sine. I know it's not cosecant. Tangent? Yep, tangent secants. And there's already the negative 5. So you can go like that. So on these problems, you can kind of find your answers as you're going. So let's look at some that have an inside function. So let's take a look at number 13. Number 13, I'm going to do the full way. And then 15, I'm going to analyze. 14, 15, I'm going to analyze a little bit differently. Okay, so I've got this 4. I'm going to move that out front. I should rewrite the whole thing. Hold on. Okay, so I've just moved the constant out front for right now. I don't know if I'm going to need it or not. So I'm going to look at this function here. And I know that the derivative of the inside of this function right here is going to be 4x. So I would need to have a... Whoa, I've got an x lying around. What do you know, Emily? Did you see that? I'm going to move that x right over to here. Oh, I ran out of room. Hold on. But I still need a 4, so I could... Oh, wait a minute. I already have a 4 lying around. That doesn't always happen, but it did here, so I already have the 4, so I'll just move this 4 over. And now I always use my little bracket here to say, is that the derivative of the inside? Is it ready to go? It is, so boom, when I integrate, that thing is gone. The integral of something to the third is 1/4 something to the 4th plus c. And I'll look at my answers. I see 1/4 something to the 4th plus c. Now, when you're working on these as you go on, you can absolutely try to shortcut the problem. For example, when I look at number 4 right here, I see I'm already to the 5th power, so I know my integral right there is it's straight to the 5th power. Sorry, so I know my answer is going to be one number higher, so I know it's going to be the 6th. And take a look. A lot of these answers are already gone. I can go with that right there. If I take a look at number 15, I can see my outside function is to the 3rd power. That means my answer is going to be the 4th power. So this time I couldn't eliminate as many possible choices. So I know it's going to end up being one of those. So this one I would have to analyze. What is the derivative? Let's write it out. Do this one here. Okay, so we're going to do this one the long way. The derivative of the inside function is 25x to the 4th. I would need to have a... I do! I have it lying around already. I can't believe it. So all I'm going to do is move this part over to here. I usually just cross it out because I don't have a... Then I make this. Do I have the derivative of the inside function sitting there? Yes, I do. So I integrate. Shablam. It's gone. The integral of something to the third is 1/4 something to the fourth plus c. And I'm checking my possible answers. There it is right there. So you can see how you can get a hint on the multiple choices, how you could possibly see some answers there. And the only thing they can kind of do is add an advanced layer to the problem. So here's number 22. Let's take a look there. So we've got the integral of something to the -5th. I'm going to try to work right off this page right here. The derivative of the inside is going to be... Well, let's write this out. Okay, so let's start by identifying the derivative of the inside. Derivative of 5x to the 4th is 20x to the 3rd. So you can do this whichever way you want. I try not to mess with numbers I already have. Okay, there's 60. So I need there's 60. I'm going to move to the outside for right now because it's already there. And now I have an x to the 3rd, but I need to put a 20x to the 3rd here. So I'll do 1/20th on the outside. And so I've got 60 over 20 times that integral. I now have the derivative of the inside sitting here. So I can integrate, skadoosh, it's gone. Something to the -5th becomes something to the -4th times -1/4 on the outside. And I already have this 60 over 20, and 60 over 20 is actually 3. So without having to go farther into the problem, I already know which one it has to be. It has to be B, because it's -3/4 5x to the 4th plus 3 to the -4th. Because it's to the -4th, I can move it to the bottom of that fraction. So we can go, let's just move our skadoosh. We'll erase that. That looks terrible, I know. Josh made me do it. So that's how that answer comes out. So you should get up to about number 20 for today. If you have questions, let me know, and I shall see you tomorrow. Take care.